everyone, a warm welcome to the 8th part of problems in wave equation. We solved the wave equation by variable separable technique and its link is, we got the solution as y of xt is equal to c1 cos px plus c2 sin px into c3 cos cpt plus c4 sin cpt. Here c1, c2, c3, c4 and p are arbitrary constants. We can find these constants by applying its boundary and initial conditions. If L is the length of the string, then boundary conditions are y of 0t equal to 0 and y of lt equal to 0. Also, if the initial position of the string is f of x and the initial velocity is g of x, then initial conditions are y of x0 equal to f of x, dou y by dou t at t equal to 0 is g of x. By applying its boundary and initial conditions, we got the solution of wave equation as y of xt is equal to sigma n1 to infinity sin n pi x by l into a n cos n pi ct by l plus b n sin n pi ct by l. Here we can find a n by using the equation a n is equal to 2 by l integral 0 to l fx sin n pi x by l dx. Also bn is 2 by n pi c integral 0 to l gx sin n pi x by l dx. Really, y of xt is the displacement at any point on the string at a distance x from the origin and at any time t. We have to find y of xt when fx or gx or both are given. See, in this video, I am going to solve a problem in which both fx and gx are given. Let me start.
Consider the question. A tightly stretched string with the fixed endpoints at x equal to 0 and x equal to 1 is initially in a position given by fx equal to x for x0 less than or equal to x less than or equal to half and 1 minus x for half less than or equal to x less than or equal to 1. If it is released from this position with the velocity a perpendicular to the x-axis, find the displacement at any point x of the string at any time t greater than 0. A similar question which we have answered in a previous video with the same initial position and initial velocity is 0. But in this question, initial velocity is not 0, here it is e. That's the only difference. Let me start to answer the question. See, from the question, it's very clear that length of the string is 1. So we can write the boundary conditions. Y of 0 t is equal to 0 and y of 1 t is equal to 0 for every time t. Again, the string is initially in a position given by fx. That is, y of x0 is fx and it is given by x for 0 less than or equal to x less than or equal to half and 1 minus x for half less than or equal to x less than or equal to 1. Also, the initial velocity is given as a. That is dou y by dou t. At t equal to 0 is a. This is equation number C and it is D. We have solution of the wave equation is y of xt is equal to c1 cos px plus c2 sin px into c3 cos cpt plus c4 sin. Next, substitute equation A in equation number 1 as we discussed with the previous problems. So you have to write y of 0t. That is, you put x equal to 0, only x is here and here. When x is 0, this term is c1 and this term is 0. So c3 cos cpt plus c4 sin cpt. y0t is 0, which implies c1 into c3 cos cpt plus c4 sin cpt equal to 0. This implies c1 equal to 0. You put in equation number 1. So we have y of xt is equal to c2, since c1 is 0, so this term is c2 sin px, c3 cos cpt plus c4 sin cpt. That is equation number 2. Next, we have to substitute b in 2. Y of 1t. For getting y of 1t, you put x equal to 1. See in the right side, you can see x here only. There you put x equal to 1. So y of 1t is c2 sin p, c3 cos ppt plus c4 sin cpt. Given y of 1t equal to 0, which implies c2 sin p into c3 cos cpt plus c4 sin cpt equal to 0. Implies c2 sin p equal to 0, which implies sin p equal to 0 because c2 cannot be 0. So this implies p equal to n pi for n equal to 0, 1, 2, 3, 4, etc. So now we got the value of p. You put the value of p in equation number 2. So your equation number 2 is y of xt is equal to c2 sin n pi into c3 cos cn pi t plus c4 sin cn pi t. See, this is the solution when p is equal to n pi. See, this for n equal to 0, 1, 2, 3, 4, etc. But if you put n equal to 0, you can see y of xt equal to 0. That is, there is no displacement at any point on the string at any time, which is impossible. So we can't put n equal to 0. So n is 1, 2, 3, 4, etc. When n is equal to 1, we get one solution. When n is equal to 2, you get another solution, etc. So you can write the general solution of the equation as sigma n1 to infinity sin n pi into here c2 into c3. It's an arbitrary constant. It depends on n. It is an cos cn pi t plus similarly bn sin cn pi t. See all these things, everything I explained in a previous problem. So this is the solution of the wave equation, that is y of xt is equal to sigma n1 to infinity sin n pi into a cos n cn pi t plus bn sin cn pi t. That is equation number 3. Y of xt is given by this equation number 3. So in equation number 3, we have to find the arbitrary constants an and bn by using these equations. An is 2 into integral 0 to 1. See, fx is defined in the interval 0, half and half to 1. So we have to split the integral 0 to 1 as 0 to half, then integral half to 1. In 0 to half, fx is x sine n pi x dx plus, in this interval it is 1 minus x sine n pi x dx. That is 2 into, you have to integrate this by the shortcut method as I illustrated in the previous videos. You start with the polynomial, assign alternate signs by starting with the plus sign. Next you write its successive derivatives. Its derivative is 1, so you can stop it. Next you consider this second term. You write its integral here. It is minus cos n pi xy n pi. Its integral is minus sin n pi xy n square pi square from the limit 0 to half. Now first integration is over. plus, you start with the polynomial, assign alternating sign, you write its successive derivative, its derivative is minus 1. Here, you have to write the integral of this term, it is minus cos n pi x by n pi. Here, minus sine n pi x by n pi from half to 1. Next, to simplify the signs, 2 into minus x cos n pi x by n pi plus sine n pi x by n square pi square from 0 to half plus, you adjust the negative sign here, then it is x minus 1 by n pi cos n pi x minus sin n pi x by n pi. Next, we have to substitute the limits. While substituting the limits, you have to keep in your mind the results. Sin n pi, what is sin n pi? Sin n pi is 0, cos n pi is minus 1 raised to n, sin n pi by 2 and cos n pi by 2 are that terms itself. Next, we have to simplify. We have to substitute the limits. So 2 into, when x is half, it is cos n pi by 2. So minus half cos n pi by 2 by n pi plus sin n pi by 2 by n square pi square minus, when x equal to 0, this term is 0 and sin 0 is 0 plus, when x equal to 1, see this term is 0, 0 in this quantity will be 0 minus, when x equal to 1, it is sin n pi, it is again 0 minus upper limit. When x is half, minus 1 by 2 by n pi cos n pi by 2 minus sin n pi by 2 by n square pi square. Here it is n square pi square. So there is a small mistake while writing the integral of cos n pi x by n pi. It is minus sin n pi x by n square pi square. It is 2 into minus half cos n pi by 2 by n pi plus sin n pi by 2 by n square pi square plus 1 by 2 cos n pi by 2 by n pi plus sin n pi by 2 by n square pi square. It is, you can see these two terms cancel each other and we have 4 sin n pi by 2 by n square pi square. See, this is our required area. So in the equation number 3, now n is given by 4 sin n pi by 2 by n square pi square. Next we have to find Bn. What is Bn? As I mentioned earlier, Bn is 2 by pi c integral 0 to 1 gx sin n pi x dx. What is gx? Gx is given as, see this is our gx, our initial condition regarding initial velocity is dou y by dou t to t equal to 0 is gx and it is given by a. So gx is a. You put gx is a and integrate. You will get Bn. That is 2 by, it is n pi c. N pi c integral 0 to 1 a sin n pi x dx. This is equal to, here a is a constant, you take it outside, 2a by n pi c integral 0 to 1 sin n pi x dx. That is 2a by n pi c. What is integral sin n pi x? It is minus cos n pi x by n pi from 0 to 1. You take the constants outside, that is minus 2a by, you take n pi outside, that is n square pi square c. Cos n pi x from 0 to 1, that is minus 2a by n square pi square c into, when x is 0, it is cos n pi. Cos n pi is minus 1 raised to n minus. When x is 0, it is cos 0, that is 1. That is, you take the negative sign inside, it is 1 minus minus 1 raised to n by n square pi square c. This is our Bn. Next you put an and Bn in equation number 3. So equation number 3 becomes, see, this is our Bn. So equation number 3 gives y of xt, that is our required displacement. It is sigma n1 to infinity sin n pi x into an. An is 4 by n square pi square sin n pi by 2 cos c cos n pi ct plus Bn is 2a into 1 minus minus 1 raised to n by n square pi square c into sin n pi ct. So this is the required displacement of this string under these conditions. Again, you can express this in the form of by taking constant outside. It's not necessary, but it is 4 by pi square sigma n1 to infinity sin n pi x sin n pi by 2 cos n pi ct by n square plus, here you can take the constants 2a by pi square c outside into sigma n1 to infinity 1 minus minus 1 raised to n sin n pi x sin n pi ct by n square. You can start the procedure here. See, this is the required displacement at any point on the string.